can see a bit more of this. We can also, get pods. We can describe pods. We can also look at pods inside namespaces. We can pass in the names of things. Just a brief reminder of some of the things that we talked about yesterday, right? Now, we seem to have a lot more people. I've been hearing them coming in, chiming away. It's been going. How many people are we up to now? 25. We've still got a few people to come ready to Jeremy, who's going to be with us for the next 2 days, and who's very kindly letting people in as they arrive for me so I can carry on teaching. Now, yesterday we covered deployments, and we got as far as the first lab on deployments, which is down here, right? So we did Kubernetes engine deployments. What we're going to do now is move on to the next kind of workload, and this is jobs. Deployments are for long-lived things. Otherwise, whereas a job runs to completion and is done. Okay. Just before I do that, what I'm going to do is I'm going to go back to the labs now, and I'm going to temporarily deactivate the lab that I turned on when requested yesterday. The reason I'm deactivating, oh, there's one lab running. Somebody's doing a lab. Jimmy, are you still working on the lab? Are you there even? Jimmy, are you there? Is Jimmy in the class? Not seeing him. So maybe Jimmy's just decided to do the labs and not join us. We shall see. I'm reluctant to just kill it, but I will turn it off when we come to do the next lab, because I don't want to confuse you about which lab. Oh, there's a message there. Let me have a little look. Was that a hand up, was it? Or was it just something in there? All right, you're just giving messages. Okay, fine. If you have questions, I'm not going to kill it now, but I am going to kill it when we come to do the other lab, so you don't get confused. I will reactivate it later on. I'm just tempted to kill it anyway, but I'm not going to. I shall be good. Okay, let's press on with jobs. This is why I don't like to enable labs in advance. You see, it causes all sorts of confusions. So, jobs. Now, the job runs to completion and then it's done, unlike a deployment, which is sitting up there permanently, right? Why might you do that? We then have a job to transcode the video file. Our job is started on the cluster. If it fails, maybe our node gets garbage collected on an auto scale downsize, so it isn't completed. At that point, it'll restart it until it succeeds. So we have something that needs to run to completion and only takes it off when it is complete. That's the basics, but there's a lot more options than that. So for example, that have multiple instances of a job, and they can be non-parallel or parallel. So this is completions 3. Your default is 1 completion and it's done. But it may be this is something that needs to happen a number of times. So you can specify a number of completions. If you put them in parallel, then they're not going to happen sequentially, or at least not entirely sequentially. So here we've got 3 completions, but 2 of them in parallel. So here's a job where we are computing in part, running a command. We've got the standard Perl image. We're passing in a command. I think it's interesting to see you can do this in YAML. Look, we're actually just passing in an argument to it, and it's going to run, right? So we've not created any special container that's doing some job. We've just passed an argument into a standard Perl container. This restart policy never can be a little bit misleading. It's not saying it won't retry the job. The question is, if it fails, does it create a new pod? The pod. Restart policy never means don't restart the container inside the pod, start a whole new pod. Back off limit 4 is, well, how many times do you try before you say, I'm giving up, this has failed? So we've got standard job here, it's kind is job. We have a template just as we did for deployment. We can apply it, do it declaratively, and look, what we've got down here is a run. So we're doing exactly the same thing there, imperatively rather than declaratively. Now, we talked about this parallelism a non-parallel, unparalleled job. So this is happening sequentially. We have our YAML file or our imperative. I apologize for all the beeping, by the way. Unfortunately, I can't turn it off. So as people keep coming in, you will hear that beep. I apologize. I wish there was a way in Meet to just say, please don't beep me, but I can't. Anyway, we have this YAML file or imperative, creates a job object. And of course, because it's a workload, it creates a controller to watch the job. So if it completes fails, then it will start another job until it completes, or we've reached that back off limit. Now, when there are, as an alternative sequential, we have parallelism. So we can have multiple instances running side by side. And there are two different ways of running this. The first one is with a completion count. The idea is you want to run it a fixed number of times. So we want 3 completions, 2 of them in parallel. So it creates two pods, it creates a third pod. When the second pod completes, it doesn't create an additional one because that will bring us to 3. So it just waits for pod 3 to complete. So it's done 2 side by side for a total of 3. The alternative is parallel jobs with a worker queue. So what we have here is no completion count, parallelism. Now what happens here is as soon as one of your pods completes, the entire job is complete. So if your container I'm done shuts down, exits, that's saying we're done. We don't need the other 2. So you need to write it with that in mind. The idea of this kind of thing is you're perhaps reading off a message queue, and you wouldn't exit and signal we're done unless all of the messages have been successfully read off the message queue. So it's for that kind of scenario. But bear in mind, one completes, they'll all be shut down. Inspection of a job is exactly of deployments. It's describe, it's get, it's passing flags. It's exactly the same. Scaling, same old, same old. You can do it imperatively. You can do it through the UI and so forth. Now, if we want to fail a job, right, back off limit is how many times it should try before it gives up and says this is not working. And this active deadline seconds is if it doesn't complete within this time, then fail it. We can delete them, same old, all this stuff. This is what I really like about kube control as a command line. Right? It is consistent. So once you've done a little bit with it, it's very easy to work out what the commands are going to be. So it doesn't matter whether it's a job or a deployment or other things that we'll see. Delete -F points to the configuration in the YAML file, deletes everything that's defined inside that YAML file. Delete the job, that's imperative. So we just like delete deployment. And I always have to look at the notes because I always forget exactly what cascade means, right? Let's have a little. Yeah, if you want to retain the job pods, set the cascade flag to false, right? So the idea is when we delete the job, stop the job running, do we retain the pod, presumably for greater speed of restarting it? It's not something I ever do. Now, there's a subset, additionally, of jobs called a cron job. This is based on Linux cron format. I apologize to the British people. I will speak American for most Americans here. You can schedule it. It still makes my skin crawl. Schedule. You can schedule it to run at a particular time. And you can go down to, dates, and once every month. You can go up to every hour, every minute, whatever is appropriate. Just look it up, Google it when you need to know the standard formatting rules. So now, instead of being triggered because something has happened and you run the YAML, you apply it. So that one is going to run every minute, and it'll spin up the pod and it'll do whatever is necessary. Now, this starting deadline seconds, the way that the cron jobs work is it has a limit of 100 fails before it gives up. Because what you don't want to have is you've got a job that's failing, that's running every minute, that just fails and fails and fails ad infinitum and uses up too many resources. So what it does is it looks back this failed since it was last scheduled successful. And if it reaches 100, it stops scheduling. It says, right, this is not working. Now, what happens if your job is failing because it's already running or something along those lines? It's going to check every 10 seconds, do I need to run the cron job? Right? Now, if it's only running every minute, the potential is there that our job might overrun. And if we've got concurrency to not allow, our job potentially will fail. What you can do with the starting deadline, counting it as a fail every time it doesn't run, you keep on trying to run it within that deadline, and only if within that deadline does it fail to run, it counts as an actual fail and gets added to your total for summing up, you know, does this job, has it failed really permanently? And as I was mentioning there, we've got the concurrency policy as part of that. You can forbid two of them running at the same time. Now, we can restrict the history. If you mess with successful job history, and particularly failed job, expected consequences, because you're messing with, should I stop this or not? So be very, very wary of messing with those, but you can. If you imperatively suspend a job or even change the YAML, suspend true will be set to true to stop it and suspend it and not run it at the moment. So same again, cron job, just like a job, you apply, you describe, you delete, same old, which is really nice. So now we're going to have a go at our next lab, which is deploying jobs on Google Kubernetes Engine. And I'm going to go back here. Yeah. Jimmy, are you here? Have you joined us? Or are you off doing that lab and ignoring the lessons? Let's have a little look. I'm going to put my reading glasses on because it's quite small. Is Jimmy in?
Nope, I'm here.
Right, Jimmy, are you actually doing that lab?
No, I think I got it hung up in one of my windows and I didn't end it.
Right, okay, not a problem. What I'm going to, the reason I just didn't want to deactivate the lab if you were confused.
Go for it.
Since you're not doing it, I'm going to deactivate it now, and I'll reactivate it when we come to do our next lab. So I'm going to enable the correct one now, which is deploying jobs on Google Kubernetes Engine. So that's now activated. Let me have a little look at it, remind myself of how long this one takes. Let's have a shufty. That was very English, wasn't it? Shufty. A shufty is a small, quick look, if you're not familiar with the phrase. So we're going to define and deploy a job manifest. That doesn't take very long. And then we're going to do like 20 minutes or so. Okay, so it's 20 past 9 Central Time. I'm going to work on the assumption that we're going to